Okay, let's see. Did this work? Okay, cool. And then ba 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 ba. Let's restream and Twitch and YouTube, which should be how annoying. Why does it always do backup too? It's so weird. So YouTube still wants to make me click go live manually. Okay, so if I go here, no, it's not made for kids. Then we're good. And then we pop that out. I feel like I shouldn't need to do that. I mean, I guess we will though. Let's just double check here. Is that? Oh, I bet you the settings are off. Oh no, I guess settings should be on. Let's just double check here. Is that? Oh, I bet you the settings are off. Okay. Oh no, I guess settings should be on. Let's just double check here. It appears to be working. And then we have chatbot dot, and then we have another chat overlay that we can, in theory, pop this out to. Let's launch this, go here. We're gonna trigger a fake test message, make sure that's okay. Yep, we're good. Okay. Well, I installed a new IDE. We might as well put her through the paces, right? But first, delicious royalty-free soundtracks, perhaps, somewhere? Hmm. I guess. Do I want music even? Because I kind of want to listen to this video thing. I'm probably going to need to listen to it a couple of times to actually get it. Let's see if she'll do it. Looks like she will. Cool.
Thank you for inviting me to this. It was great fun to be in Chicago. I've never been in Chicago before, so it's quite an experience to be here. It's quite unusual to find it colder indoors than outdoors, because in Stockholm it's the other way around.
So we want to,
Thank you for inviting me to this. It was great fun to be in Chicago. I've never been in Chicago before, so because once I've isolated all of these, I can now go around the room turning off one at a time, changing the coding. The plan for this talk is I just sort of introduce the problem domain. It's this highly concurrent, highly connected world. Just talk about some algorithms and architectures, and then I just go into what I call 6 rules for making systems.
cool.
I'm kind of not so interested. I mean, this might sound funny coming from me. I'm not really so interested in programming languages. I'm interested in solving problems. Erlang's one of those languages that was developed to solve a specific problem, and it turns out to be very good at solving that problem. Surprisingly, it's also good at solving other problems, but that's not by design, that's more by accident. And I'll talk about the reasons for that. Given that you've got those 6 rules, you could actually implement them in any language you like. If you constructed the language to have certain properties. You can bolt these properties on top of other language. They weren't explicitly constructed in that way, so you get the sort of feeling for it, but not the behavior that you get in Erlang. And I'll show you how they're programmed in Erlang. Right, so what's the problem domain? Well, I want you to think about, somehow we've got to go from this. That's a sequential program. That's all sequential programming languages look like that to me. There's just one sort of thing, and you've got to do everything in it. Right, that's all sequential programming, and here's Erlang, you see.
Okay,
so
so
it doesn't look like that. It's a completely different world, you see. You're not talking about one process or one computation that's going to do everything. You're talking about thousands, possibly millions of computations that are going to do things. And they're all isolated. They're all doing their little things, and they're all talking to each other. So we have to understand this sort of world. I don't want to understand that other world. That other world is a very strange world. I mean, if you're programming things in the real world, they're parallel. I mean, the real world is parallel. Hundreds of people in this room. It would be extraordinarily difficult to try and describe that in a single I mean, how would I describe it? You're thinking that, and then I sort of interleave, and then you're thinking this, and then you're thinking that, and I go around you all, and then we get back to you. And how would you program that? I couldn't program that, but I could program it as, 300 parallel processes. I always like to think of Erlang processes like little people, because we've all got private memory, and we all communicate by message passing. I've got my memory, you've got your memory, and I speak to you, and the words go. And this message passing channel is imperfect. You might not be listening when I speak, or a jet might go by and obscure the noise, you don't hear it. So that's really how my little processors work. They've each got private memory. They just send messages to each other. We don't know if the messages get there or not. If you want to know if a message got there, you've got to send a message back. Then you'll know it got there. So we're not really making any big assumptions about how the world behaves. And this is actually how, I used to be a physicist. This is how a physicist would view the world. There's no such thing as simultaneity. We don't know what's happening now. We know how it was at the time it takes a ray of light to go from A to B. I don't see you now. I see how you were a micro or a picosecond earlier because of the time it takes light to get from me to you. And it's the same with software. When we send messages to each other, we don't actually know how they are now. We know how they were in the past. And we have to live with that. Well, we can't change the laws of physics. We have to live with that. So this world has got lots and lots of computers. Lots is a sort of rather vague term, but it could be anything from, I wouldn't call 2 lots, but it's certainly more than one. Probably lots starts at about 10 and goes up to a few tens of thousands, possibly millions of computers. We don't actually know how to program millions of computers in Erlang at the moment because we haven't got millions of computers, but there are research projects who are figuring out how to do that, actually. The million-core CPU sort of projects are sort of going on to the research horizon now. Of course, if you've got this world with lots of computers, they're all executing things in parallel, and it's distributed. It's concurrent because they're all running at the same time.
Wow,
and faults are going to happen.
They do.
And so it's not a question of saying, well, let's use type systems or let's use something so that no faults can occur. It's more the case that faults are going to occur, and then you're going to have to detect them and do something about it. You're going to have to worry about consistency, or rather the lack of consistency. I mean, if you've got thousands of computers, it's just kind of unrealistic to think you can put it into a consistent state. So you're going to have to live with inconsistency. And if you want it to run forever, you're going to have to change the code in it as it's executing. I mean, you just cannot, there's no such thing as an atomic upgrade. Stop it, change the code, restart it, if it is every single computer on the planet. It's just not going to work. So you're going to have this notion of things sort of partially upgrading themselves, and an upgrade to take time, and of living with different versions at the same time. So one of the things, actually the primary thing that Erlang was designed to do was to do fault-tolerant computation. So let's just think about that for a moment. So there's this kind of world. There's really 2 ways to design things. You can either sort of start with small things and scale them up, or you could start with big things and scale them down and see if you get it the same way. So suppose you're building a system and you want it to be, suppose you want to build a system for like 10,000 people to use simultaneously. One way of doing it would be to start with the system, design it for 10 people and test it like that, and scale it up to 10,000. The other way would be to design it for like 100 million people I mean, do the design for that and then scale it down to 10,000. And you might get a completely different architecture. In fact, you would get a different architecture. And I think in general it's a really bad idea to start at a design that works for 10 or 100 things and scale it up. It's better to start with an architecture that you know will work for a few trillion things and scale it down. It will actually be less efficient when you've got your 10,000 than the one you scaled up, but you'll know that you'll be able to scale it up later. So it's good. So rather than ask how do we get to 5 nines, I'd really like, let's make it more interesting. Let's start at 9,999 nines reliability and scale it down. Okay. So let's make a system that's got 9,999 reliability. Well, that's easy. Well, it's not quite easy. There's a tricky bit, right? So, well, that's really easy because if things are independent, this is just probabilities. If the probability that one thing fails is 10 to the minus 3,
oh yeah,
just get 3,333 independent machines and run them all in parallel. And the probability they all fail at the same time is 10 to the minus 9999. So you've got your 4 9, oh, it's not 4 nines reliability, it's 9,999's reliability. That's pretty easy. Okay, so the difficult bit is making them independent. Right. So, oh, and does this work? Yeah, I've just put in a few slides to show that well, we believe this sort of technology works. This is this is what I do, right, when I'm not here. I work for Ericsson, and this thing here
right.
is a connection, but this stuff down here, this is your 4G, LTE, wideband CDMA, 3G out here. And this stiff stuff over there, IP network, that's internet. Right. And we put a box, so the software abstraction of that is this. Okay?
Fancy new.
Well, software people do bubbles and arrows and things, you see. So this is millions of smartphones, and that's Erlang, and that's the internet. And that box in the middle, that connects smartphones to internet. Now, it actually connects about half the smartphone traffic in the world. Right, so if you've got a smartphone, and if you're using data traffic, then there's about a 50% chance you're going through an Erlang thing. If the base stations are programmed, if you've purchased your base stations from Ericsson, okay. If you've purchased them from our competitors, then they won't be in Erlang, they'll be in C++ or something like that. So it's about half the world's smartphone traffic is going through these things. And we built a thing here. This is Ericsson. I've just sort of taken some stuff. I showed you the first picture, that was the architect. The second one's the software abstraction. This is the sales abstraction, which I showed to customers. That thing is a box. It's a big sort of box. And it's not really very exciting, actually. But it's one of those boxes, right? We don't sell many of them, actually. Has got the goals are 6 nines reliability and 18 million simultaneous connected subscribers and low power consumption per person. That's all programmed in Erlang and works quite nicely. Thank you very much. So this is pretty similar to internet high availability. There you want sort of thousands to millions of users, kind of soft real time, upgrade them as they go along. You don't really stop these systems. I mean, Google doesn't sort of go offline to do code upgrade at midnight.
Oh, hello. Is there another person?
You know, there isn't really a midnight.
Yo.
When it's midnight here, it's not midnight.
Let's take a look. Oh, it's red. How's it going, buddy?
So there's not really a midnight. Perhaps they stop.
Hey man, sorry, I'm stretching. Dude, what do you like even do in the server? Like, I appreciate you hosting these voice channels, but I mean, like, when you say Jupyter all over a paper, like, what?
Well, currently the plan for today is, or the general plan for Sundays, is to find cool paper and then either run code that exists just to see it run, I guess, and like, you know, play around with it if it's doing something cool, or find a cool paper that we would like to have code for, and then if there's somebody that is smarter than me in attendance that can help me figure it out, then try to implement it. Sometimes that somebody is GPT, and sometimes it is smart enough, sometimes it's not.
Yeah,
But
that's funny. Yeah, I don't think I've ever done anything like that, and probably don't have the time because I'm catching up on stuff right now, but I thought I'd pop by anyway because this place is cool.
Oh yeah. Well, I appreciate it. Yeah, unfortunately, I freaking had to go get a job, so I might be able to do less things than I would like to be able to do in the near future. But I still have a couple on the list that I want to see if I can fit in terms of
Hell
like
yeah.
actual events. I know there's a few people from Latent Space that want to do like a hackathon around transforming data prior to vectorizing or prior to embedding that I want to try and make happen. And then I feel like there's a second one, but I don't remember what it is. But we'll see what I have time for.
Even like, problem is I'm not even like close to good enough to be doing most of this shit. Like I hang around here, and I know I can get there in like a year of just like grinding it up, but like, ugh, it's like frustrating when you don't understand half the words. You know what I mean?
Yeah, well, and I still get that sort of semi often, I guess. I don't know, or like I have the same issue where I'm like, I'll go to start implementing something and then I'll run into a problem and then it frustrates me and I stop and I go look for another thing to play with. But supposedly that's something that one can learn to tolerate. We'll see.
It's interesting. Who the fuck is posting? Why is someone posted a data science role in Jacksonville, Florida? I don't know whoever posted that or why, but yeah, terrible idea to move there. Are you in the Bay
Jason
still?
just likes to post whatever he sees. Am I what now?
In the Bay?
In the Bay. I never was in the Bay. In fact, I am.
Oh, I thought you were.
Yeah, I'm a little farther north, kind of like Oregon-Washington border, but I try to do stuff that is near, or like, if cool stuff happens in the Bay, then I try to do like some corresponding thingy, so that may be where you got that
No,
impression.
that's cool, yeah. Yeah, I think so, yeah. I don't know, I just made the assumption, I guess. But that's, yeah, that's, wait, Portland?
Yeah. Oh, did I just leave it? Oh, no, I didn't leave it. Okay, we're good. Yeah, Portland.
Portland's sick. I used to want to move there. I don't know how good, like, terrible it is now. People keep saying it's terrible.
It certainly has changed a bit, I do believe.
Do you think it's livable?
Well, yeah, so it's a lot more expensive and it has a lot more, I don't know, like homeless people, I guess, for lack of a better term for
Well,
it.
yeah, no, I mean, yeah, it's kind of like overrun is kind of the issue I'm referring to here.
Yeah, I don't live in Portland proper. I'm like just outside of it, and it's generally fine for me. But it's mostly like if you can afford it, then it is a decent place. But I haven't like lived in a lot of different places. So.
Do you have the gondolas? Do you take that at all, or is that like a gimmick?
I don't even know if presumably there are some somewhere that sounds like a Portland thing, but I'm not super familiar.
Okay, cool. No. Cool. Yeah. Anyway, fucking, what was I gonna say? Oh, yeah, do you guys do any, like, computer vision stuff in here? If you ran a computer vision hackathon or anything like that, I would totally join.
Interesting. Noted. I have not. I will put it on my list of things to run. It's not a. I don't personally know a lot about computer vision, but it's an interesting topic, especially considering that we're getting pretty like multimodal these days with Gen AI.
Yeah, I mean, well, I mean, it's AI oriented, but I don't know, is there any like specific theme to the server that you really have to stick to other than just AI?
Nope, it's my server. I do what the fuck I want. It doesn't even have to be AI.
Hell yeah. Cool. Should do like a basket weaving competition.
Fuck it. I totally could. My old school RuneScape basket weaver who can go the fastest. Let's fucking do it.
But one thing is, hold on, wait. I don't know. I use PyTorch at all?
Yeah, a little bit.
Okay, I was gonna learn. What are your thoughts to learn PyTorch? I was going to just recreate this. Hold on. Wait, I lost it. I lost the tab. where I'm in Discord. Oh, there we go. General chat.
These machines to store it on. And if you want
Do you think that's like a good place to start?
General.
Just at a glance.
Build an AI ML tennis analysis. I mean, off the, you know, from the YouTube thumbnail seems as good as any.
Right. And it's
In
actually the
terms of
basis
ones
all-
that I really like, in terms of, do you know Vast AI? I think Vast.ai
Nope.
course. So places I would
let's
look,
make replicas.
or oh, maybe it's
find the
Fast
data.
AI.
That's not a problem.
It's
That's
one of
pretty
those
easy.
Fast
But I'm trying to
AI
replicate
course,
data
practical, yeah,
in
practical
case the
deep
machine
learning for
crashes. So we're storing
coders
in 2 or more
is
places.
the classic.
Now life
Right there.
becomes a bit more
And
difficult.
then
So
the
first thing
other
is,
one,
the first thought that people have about
and then I
replicas
think
is,
deep
I know what
learning,
we'll keep an odd
learning.ai. Now these aren't necessarily
And we'll vote.
PyTorch only, of course.
You know, you'll send out, like,
And I
say,
don't
5
know off the
machines
top of my
and
head if
send them
all of
out.
them, if it's
And
all
3 of the
PyTorch or if it
machines
goes
have
to like
said,
Keras and
we
TensorFlow
agree.
and all that
And
stuff.
then you say, yeah, it's okay. What about the 2 that didn't agree? Well, forget about
But
that for
the
a moment.
other
This,
place I
we'll
would
forget
look
about them for a moment.
is
It's gonna come
this
and bite us
place.
in the
Deeplearning.ai has shorter courses that are quite
later.
good.
But never mind. It
Thanks.
looks okay.
And I have a
majority,
hidden
and what
one.
about time?
Where is that?
Oh,
Let me
oh,
go
brilliant.
in my Obsidian. Gates.
We've got some master machine
Gates. List gates.
And
Da-da-da-da-da-da.
it's broadcast to 5 machines, and then it gets 5
Which
answers.
ones?
But
Is it
all this
this?
takes place in parallel.
Yeah.
Okay, so in wave 1,
Let's see.
you
Can
send
I
out
go
5 messages, and then you get 5 replies.
frickin'
That's great. Fantastic.
Okay, I think I think I can find it on Google if I do this. Transformers from
So you
scratch.
can have 17 replicas, or you can have 9,999 replicas, and wait until more than half of them are replied, and you're okay. Isn't that easy? You see, it's linear time. Doesn't matter how many replicas.
Okay, what if I do
Find the
this?
machine. Everything's simple.
Yeah.
Yeah.
Arena.education is the one.
You're thinking,
This one.
Oh, is this the one? It's got like a red something to it. Hold on. Wait.
so making replicas.
Yeah, this is the one. Okay, this one is like I need to work up to doing this one, and then once I can finish Arena, then I'll be good.
Let's look at 2.
Yes.
Yeah, it's pretty difficult.
The other one, the last one I think that is jumping to my mind is the Carpathy course, GPT-2 from scratch.
Complex language is a seminal characteristic of large language models.
Oh, is that one like? Isn't that like a like really long YouTube video?
Let's suppose
Yes.
we've got a master machine A.
Yeah.
Or rather, that is a series of really long YouTube videos. But it is a playlist from Carpathy. I think if you
I
were
see.
to, yeah, neural network 0 to hero, that's the one.
And what
It's
we
right
know
there.
about the system is asymmetric.
So between all of those, if you were to slog your way through all of them, I'm sure you would be wildly proficient. But I think the
Word.
best, let me ping, what's your fave thing of how to learn to PyTorch? Baco works with PyTorch a lot more often than I do, so he would be the guy I would ask about that in terms of stuff. But those are the ones that come to my mind, and I haven't really like gotten too far into basically any of them, so I am not the best person to have a strong opinion about them, but those are the ones that that are like on my list of, hey, if I wanted to go learn deep learning, I'm gonna go do this.
Gotcha. Thanks a ton, dude.
Yeah.
This is really helpful.
Absolutely.
Hell yeah. Thank you. I'll check it out. Thank you, man.
Cool. We'll see you around.
See you.
Okay. So it sends a message to A, set A,
We
and
did
then
our
get
good
all these
deed for the
extra
day.
values. It all
Hell
works
yeah.
beautifully. And there we go. So we set X equal to
Okay.
10. And
So
set it
the
equal
question
to
is,
20,
what is going on with
everything's
this? Gated CNN,
fine. Right.
Mamba out.
So,
Okay,
hang
well
on,
let's
what happens
look at
if
the
A
paper here.
crashes? And then the client asks for the value of X. Well, up to this point, oh, sorry. So it's crashed at this point. So the user set X equal to 10, and some stuff's worked here, and that's fine. Then he set X equal to 20, and some stuff's worked. And then this process crashes at this point here. So the master here knows that A has crashed, and now somebody asks for X. Okay.
Well,
Well,
everybody
the
knows
master
that I love
knows that A has
snakes.
crashed, so he asks B. And he gets back a value of b that's 10. So what can he reply? Oh dear, this is a sort of unsafe value of x. I know it's 10, but it might not be.
Page, single page.
Right?
What do we do?
Because you see, it's actually 20. I mean, it's been 20 here. But he can't ask A because A is dead. But he knows that A's died, and he knows that B. So, oh dear. So we've got this unsafe value of x. Now, what do you want in your program? Oh, you do a get and put into a database, and you say, yeah, what's the value of x? Yeah, it's 10. What's the value of x? 10. Well, oops, sorry. What's the value of x? Well, I think it might be 10. So programmers don't want to know this. And so other programmers put abstractions like two-phase commit. And so even though you're getting it, well, I'm unsure about this really, they say, oh, I'm sure it's 10, you know? Right.
Imagine like none
So
of
now we
that's
have to,
readable.
what
or
happens if the
whatever.
master, now, well, wait a moment, look, hang on. So this was kind of tricky. You see, here's the A has died, but the master process hasn't died, it's still living. And then it's beginning to get a tiny bit complicated now. So now we say, oh, well, what happens if the master process itself dies? Right. This is you don't want to know stuff. Well, I'm going to tell you a little bit, right? Life gets a tad tricky, okay? So have any of you heard of the Paxos algorithm? Right. So you know life is a tad tricky because of the So the Paxos algorithm is distributed leadership election. It's the problem you have a leader just dies and then you've got to, in a distributed way, figure out who a new leader is, and you kind of vote and take the majority. But as you're voting, you might lose messages and they might die. So if you look it up, say, on Wikipedia or something, you'll find these signal diagrams. They look pretty much like the ones I've been drawing, only there's about 15 to 20 of them that look like that.
Okay, 3.5.
Well, that's one of the simpler ones that will fit on the slide. So in making this lecture, I did a little bit of research, and I found a quote I rather like, because it was from a paper. The paper was called In Search of an Understandable Consensus Algorithm. I like the word sort of understandable consensus algorithm. And to read you a bit, it says, unfortunately, Paxos has two significant drawbacks. The first drawback is that Paxos is exceptionally difficult to understand. The full explanation is notoriously opaque. Few people succeed in understanding it, and only with great effort. As a result, there have been several attempts to explain it. These explanations
So does
focus
that
on a
make sense
single-degree
in the code?
Paxos. They are still challenging and leave the reader with not enough information to build a practical system. In an informative
So we
survey of
have
attendees
a
at something,
cat
we found few people who are comfortable with Paxos, even among seasoned researchers. We struggled with Paxos ourselves. We were not able to understand the original paper. That's the one Paxos simply explained, you know, so... until several simplified explanations in designing our own alternative protocols. And look who wrote it. Well, one of the authors is John Oosterhout. Do you remember TCL? Very nice language. So John Oosterhout, I mean, he's not a dumb guy, right? He designs programming languages. And programming language designers sort of a bit anal about understanding stuff. So they try and figure out how it works. So if John Oosterhout says he couldn't understand it, and it's kind of tricky stuff, that's good enough for me. You know, I mean, it is actually. So that's the bad news. Okay, so what's the good news? Well, the good news is that it's been solved in the Erlang, I'm going to say quotes, in the Erlang library.
Oh God. Whoops. Hold, please.
Erlang libraries, you see. So there's a gen leader thing in the Erlang libraries. That itself is a sort of, this problem was so difficult that we had a research project to do this, and the research bit of it was the project bit was to write the leadership election algorithm, and the research bit was to prove that it was correct, right? And they proved it was correct. And it ran for several years, and then I can't remember when it first was, but then they got a bug report.
Okay. Let's see what
That
you got.
the leadership election was actually electing two different leaders, and it was reproducible.
Okay, so this is
And
demonstrating.
this was a bit of a problem because it actually been proved to be correct.
Mamba out femto.
So we went back to the people who proved it, and they said, oh, well, we had to make a few simplifying assumptions in order to do the proof.
Mamba out femto.
So
Okay.
it's believed to be correct at the moment.
Okay, so.
And if you don't want our libraries, there are things like
This
REAC,
is not a tiger, but
which is
it's
a
a cat.
database, which
what's the
implement
thing
these
that we're
kind of
running?
algorithms. And they actually give you fine. REAC actually is quite nice because instead of sending this, normally things hide the voting structure. So if you've got 5 replicas,
Now the question
And-
is this?
you really wanted to be sure that it really worked. You'd really
Like,
like
why
to
do we
maybe
care
know that
about
you've
this
got
even?
5 commits, not 3.
Because like what's
Most
SOTA
databases
for
don't allow you to do this.
vision?
REAC has this kind of
yeah,
layer of
classification,
fine
let's see.
control where you can sort of say, well, I really do actually want to know exactly what's
Yeah.
going on, and you can sort of go in at different levels, which is very nice. So this was just a little sort of introduction to some of the problems you get in distributed programming.
VIT?
I don't
Okay.
think that you need a lot of complicated, fancy
92.
algorithms to do distributed programming. There's certain ones like replicating data you do need, and you certainly don't want to implement them yourself. So you
Okay,
really
so
want
it's
kind of
not-
rock-solid industrial quality implementations of that stuff, and don't try and
So
build it
it's
yourself.
not
Unless you're a
pushing
research group and want to spend 10
SOTA.
years doing it before you know, if you just want to build something, take these libraries and use them. You don't actually need that many. There's libraries like
Cross-model
REAC.
sharing, November
AMQP,
last
the Rabbit
year.
MQ, is a persistent message queue. Think about it, you can implement a heck of a lot of things just using persistent message queues, and it's just nice to know that somebody else has done all that work of putting that into the library. These are the libraries you want. You don't need libraries for web services. Any fool can. No, but look, any fool can write them, right? But this stuff is difficult. Okay. Right. So let's look at some rules for these are sort of properties that you
Really?
need if you want to make fault-tolerant systems. And you know when people, I don't like slides with. Well, I've got slides with bullets, but trouble with slides with bullets is all the bullet points are the same size, so you don't know which is most important. So really, I'd like a patent. Big bullets mean it's important. Small bullets mean it's not important. So if you put on a bulleted list all the things that are important, the biggest bullet of all is isolation.
Okay, so there
Processes
isn't
must, or computations must be isolated
for
from each other.
Omnivac.
That means that one process can't crash another one. It doesn't really matter if my process is, suppose I've proved my process correct and tested it and it's wonderful, and then some other bloody idiot comes along and just crashes it, pulls the plug out of the computer. I've proved your program to be correct. I've built a fault-tolerant system. We've built it on one computer, and some guy comes along and says, oh yeah, and pulls out the plug. It's not fault-tolerant, is it? So this isolation property is very important. I know, because this computer is
kind of
isolated, I know that if I just walk into the... Can I walk into the audit with... Do I have a volunteer
Considering it
who will
is.
give me one of these beautiful computers? I'll smash it and show that my slides are still working. Do we have a volunteer? Or do you believe me? Sir, can I take your computer to
Actually,
smash
I'm
it?
gonna save this
Do I need to smash your computer, or do you believe me? You believe me, right, that's great. Take the challenge, I'd be really surprised if I went and smashed a computer here and the slideshow stopped. Or if somebody smashed a computer in Sweden and it stopped. That's isolation. Okay. And we want that for our software. Right. So once you've got isolation, what does it give you? What do you get for isolation? You get a heck of a lot of nice things. You get fault tolerance, because if I just smash this machine, it's not going to cause what's going on in these other machines to stop. It gives you scalability, because if I have organized my computation so that it will run on one machine, isolated from another, then if I want twice the power or 10 times the power, just get 10 computers and put 10 of these things. So designing my system for isolation, making sure the bits are isolated, gives me scalability.
So
And it
Omnivac is
gives me
interesting to me. I would like
Reliability,
to
okay,
implement that. It
pretty
looks
much
kind
the
of
same fault tolerance.
complicated.
It also gives me
but
testability,
I
because
am
I've isolated it. I can test it
Look
in
for
isolation.
related papers, see if
If
anybody's
it's not
iterated
isolated,
on
if
it
it's lots of bits all
since
glued together,
November,
how the heck do you test
that
it?
would be really cool.
The more I can isolate the bits, the better I can test them. It gives me comprehensibility, because this act of isolation is taking things into smaller components, talking to them through protocols. That gives me the ability to test them. Okay. And it gives me the ability to upgrade the code in them. Because once I've isolated all of these, I can now go around the room turning off one at a time, changing the code in it, putting it back online again, then going to the next one. So I'm going to get all these things for free, provided I have made an architecture with isolated components. Okay, so once they are isolated, the next property I need is concurrency. Can I describe a computation in terms of concurrent processes? Because if I've now isolated them, they are concurrent. I can't do anything about that. So does my system, I'm not talking about programming, is it an operating system, a programming language, does it enable the description of concurrency in a sort of rather natural sort of way? Okay. Well, why do I want concurrency? Well, world just happens to be concurrent and parallel, just go out in the street. If you don't believe it's concurrent, just walk over the street outside there, when all the cars are whizzing by. It is, all these cars are sort of zooming around. All this stuff is happening. If you try and describe that in a sequential process, how would you do it? I don't know how. You can't. So, the world actually is concurrent. So let's try and describe it in a concurrent language, or a concurrent way. That doesn't mean to say it will execute in parallel. It means the description is as of a set of parallel concurrent activities. You see, I can't, if I run it on a sequential processor, a one-core computer, it'll never be parallel. It will be concurrent, however. I get the illusion of parallelism by interleaving the CPU. If I've got like 1,000 computers, if I've got a 10-core CPU, I can run 10 parallel processors on it. I can't run 11.
So I don't want to, can I use, is there
I
a
can run a
browser?
million concurrent processors on it, interleaving onto the 10 processors. We have to distinguish these two ideas. We also need, at least 2 computers to make a non-stop system. I always thought that was obvious until, you see, I've been working for this so long, I didn't realize that people thought, oh, you actually, you can make a fault-tolerant system on one machine. I said, well, what happens if you smash the whole machine? They go, oh, I didn't think of that. So, so Ericsson, you see, we do this sort of, Mike Williams, who worked with me for years and co-developer of Erlang, said he was, Ericsson built military systems.
Maybe semantics color?
They had a bit that built things for generals and people with funny hats on. And so this general came in and said, we've got the talk about, 2 machines, you knock one out, it carries on the other one.
Fourier prompt
and he was very pleased about this, because he said to Mike, well, I always wondered what would happen if a nuke hit one of the exchanges. So you're telling me if a nuke hits one exchange, it will still carry on going. Well, sort of Mike's mental model of this was like 2 computers sort of in the same building, stood up with a wire in between and duplicated power supplies. So you didn't have the sort of mental model of there being like 400 kilometers between them to guard from nuclear weapons. But a little bit of thought said, yes, it would work. So the general was happy. Yeah, so, concurrency, it kind of goes together with this distribution. If it's distributed, it is concurrent. You've got to live with it. You can't.
Language,
So here's the funny thing, you see. If you want to write fault-tolerant software, you have to do concurrent and distributed programming, whether you like it or not. It's not an alternative not to understand distributed programming if you want to build fault-tolerant systems. Because you do need 2 computers. They are in parallel. They are distributed. You can't get away from that. Right.
Ooh.
Next thing you want to do is detect failures. Machines are going to die. So if you can't detect the fact that they've died, you won't be able to correct any errors that occur when they die. Pretty obvious. Failure detection. Right. So, yeah, if you can't detect a failure, you can't fix it. And this has to work it's got to work sort of transparently across machine boundaries. And that implies
that's up my alley.
actually non-shared data structures. You've got to you can't have like dangling pointers over machine boundaries. You can't sort of lazily transfer data and have half the data on one machine and half the data on another machine, because if one of the machines crashes, you've lost half your data. Okay, so it sort of implies this kind of pure message passing where you copy everything. The real reason for that is fault tolerance. It's not to do with anything else. It's not to do with efficiency or anything. I mean, I always thought, first of all, you make systems right. That means fault tolerant, and then you make them fast, you see. The consequence of making them right is you can't have lazy data structures with dangling pointers over machines. You have to copy everything, otherwise you can't make it fault tolerant. And actually, I also want it to be asynchronous message passing, because you can't do synchronous message. And the world is asynchronous. Light sort of moves from A to B and takes a certain amount of time, and you can't change the laws of physics. Right. We build fault-tolerant things into little, in Erlang, we build them into trees of things that sort of watch each other. And these work transparently over machine boundaries. And this is a kind of logical picture. They could all be processors on the same machine, or they could be processors on different machines. It doesn't really matter. You need also fault identification. It's not enough to know that something's crashed. You really want to know why it's crashed. At the lowest level, Erlang gives you a kind of simple, it crashed because you divided by 0, or it crashed because something was wrong. But you can tune that. You could send a lot of entire databases with you when it crashes. You send the entire state of the system when it crashes if you want to. I said that. And then you want live code upgrade. Pretty obvious. Won't really say much about that. I did say something about it. You want zero downtime. Once you've started, there's no stop button on your software. You press the start button. That's it. Go home. It'll go forever. And you want stable storage. I mentioned stable. That's this, store my data. That's one of the tricky things to do. That's not a property of a programming language. It's a property of programming language and algorithms and operating systems and all sorts of stuff. But it's kind of pretty good now. This is kind of off-the-shelf stuff.
Okay.
It's quite
Anything
nice
more
if you've got proper storage. You don't need backup anymore. Well, what the hell have got backup for? You don't need backup. Backup's something you want in case your machine crashes, but if you've never crashes, you don't need backup, do you? So remove that. You do need snapshots, because you overwrite your data, but you don't need backups.
April.
You need crash reports and things like that. When it crashes, it's nice. It's nice if you can come back later and say, oh, well, despite it's all crashed, it's still in the storage why it crashed when we start it again. I just wrote a quick few quotes from various people about how you build fault-tolerant systems and things like that. Well, Jim Gray is actually wrote this paper, Why Computers Stop and What Can Be Done About It. Does anybody of you remember the tandem computer? Oh, excellent, good. Not the only one with grey hairs. Erlang is, in one sense, the tandem computer in software. Its architecture is very much like the tandem, because I read Jim Gray's report and I mailed him and said, Erlang, he'd postulated if you were to do all this in software, it worked pretty much like the hardware, he said. And I said, yeah, well, we've done it in software, and it does work pretty much like the hardware. And he mailed back and said, yeah, I know. It would do. He also said, welcome to the Church of Concurrency, he said in his mail, which I thought was rather nice. And he said, in order to, I just highlighted a bit, see, process achieves fault containment by sharing no state with other processes. Only contact with other processes is via messages carried by the kernel messaging system. So that was the only way that data could be exchanged in tandem. And he said, the key to software fault tolerance is to hierarchically decompose large systems into modules, each module being a unit of service and a unit of failure.
Decoder
And the failure of
say.
the module should not propagate beyond the module. This seems to me straightforward. Actually, I haven't got it on this slide, but Postel's law of making matters worse law, sort of be tolerant in what you accept. And, this is an absolute nightmare because, you send, what are you supposed to do? You define a protocol and then you send a message that is in violation of the protocol.
I really want the slides from the other week when
it's horrible.
TimeGPT came by.
Crash immediately, no. And then Gray, a guy called Gray, it's pretty much the same. Transaction mechanism in process. Software modularity through process and method, same sort of idea.
So do these guys?
And there's a notion of fail fast. The process approach to fault isolation advocates that process software should be fail fast, that either a function should function correctly or should detect the fault and stop operating. So as soon as you've got a fault, you stop. Don't make matters worse by continuing. Right.
Oh, okay. So it's just.
And then fail early. This is somebody else. A fault in a software system can cause one or more errors. The latency time is the interval between the existence of the fault and the occurrence of the error can be very high, which complicates the backward analysis of the error. This is a paper from sort of business systems. If error occurs now and you carry on and carry on and carry on and carry on and then you get the symptom, it's very difficult going backwards to find out where it occurred. Right. And who we got? Oh, Alan Kay. This is a nice mail he sent, a reminder
Yeah, I think
that it took some
someone
pains at the
mentioned
last
she was
week.
gonna benchmark
Small talk.
against-
It's not only about its syntax and class library, it is not even about classes. I'm sorry that I, a long time ago, coined the term objects for this topic because it gets many people to focus on the lesser idea. The big idea is messaging. So the big idea of object-oriented programming is messaging. It's not objects, and it's not classes, and it's not methods, and it's not how they're organized. That's abstract data types. The big idea in object-oriented programming is messaging. And
I thought she said she was gonna benchmark against
polymorphic messaging.
the other day.
Right. Of course, all
Okay,
this
well,
is
what are
in
your
Erlang.
benchmarks? LOL.
And Schneider, it's the same sort of stuff. Anyway, I summed all this up into Joe's quote, let it crash. Right, so just let your software crash. Now, crashing is a big deal in sequential programming languages because you've only got one process. So if you crash, you're screwed. Right. Well, what else do you do? Okay. So wait a minute. There's a corollary to this. All sequential programming languages get error handling wrong. Every single one. Doesn't matter what they are. Doesn't matter if they're Java, Haskell, Smalltalk. All of them. They're all wrong. Because they all have this notion of one sequential computation. You've got to do everything inside it. So you have to keep it alive no matter what happens. So what happens when you're writing a program and you get to the point in the program where you cannot return a value to something, where it doesn't make any sense to continue because you figured out that what's going wrong didn't agree with what should be. You've got a violation of your internal logic. What can you do? You have no alternative but to crash. You can't logically continue. There is no way you can. Suppose you've got a factorial. Suppose you've got a divide by x, and x turns out to be 0. What do? You can't continue in it. You can't. I mean, throw not a number or something. Come on, just crash. For goodness sake. But you see, it's not a problem if it's Erlang because you've got millions of processors all watching it. Who cares if it's
I kind of want to.
Oh dear. Right. Right, so there were 6 rules. So how are we going to program them? Well, what's Erlang? Going to program in Erlang. So Erlang's a functional program. Well, it's kind of 3 things. Which it's like, this will come, when you unwrap the parcel, you find 3 things inside it. It's a functional programming language. Probably in respect to Haskell, it shouldn't be a big F, it should be a sort of little f. It's got a few non-functional things in for pragmatic reasons. You can program in a very functional way if you want to, but you can also, don't have to. It's a set of design principles. They go under the name of OTP, which is a very self-evident name, middleware, open telecoms platform. Oh, well, we're not doing telecoms, it's useless, right? So, but that's all about fault tolerance and setting up these things. And it's a virtual machine called the Beam. B stands for, well, it was designed by Bogdan Hausman, which is why there's a B in it. So it's Bogdan's abstract machine, but then Bogdan left and Björn took over. So Björn Gustafsson now supports it, and so it's Bogdan and Björn's Erlang abstract machine. Right, so how do we program the 6-bit? Well, we could use libraries, or we could use things in Erlang that were designed to do that. Okay, so what about the okay, let's go through the isolation rule. Well, Erlang processes just are isolated. One process cannot damage another by accident. It could damage it deliberately, send an exit signal to it, but that's not accidental. You shouldn't be. Perhaps I should say you can't accidentally damage other things. And also, you can't really kill it. It might set a flag saying, no, you're not allowed to kill me. But there is a special message.
What up, Yikes? I figured I'd poke my head in for a few
Oh,
minutes.
hey, what's up, Brummy? Long time no see.
And an Erlang node can...
Yeah, I figured I'd check in for a bit. Usually when you're working on stuff with other people, the chat moves too fast to actually catch up with you. Figured you were in here by yourself for a minute. Catch up for 5 to 10 while I have a smoke.
I do be, yeah, just poking through. Oh my god, did I have my freaking browser hidden half the time?
With a few
Of course I
gigabytes of
did.
memory, you can run up.
Poking through some papers, looking to see if there's anything
Just try it at home.
worth testing out.
They've got no shared
at
memory.
the moment. What you been up to?
And they're very lightweight. They're much
Oh, last few months have been a little weird in general. Like, I was doing real good on that cleanup up until December, and then I had some appointments. I went out for New Year's, and I was trying to get back at it in January, and I went out for a birthday party with some of the new friends from New Year's, and I had that little car crash at the end of January. And then, like, that didn't fuck me up too bad, but, like, I was in recovery from that, just doing massage and stuff, and they ended up going hard on the fucking Twitter account building for, like, 3 months and, like, super focusing on that, because there was, like, no interesting AI news for a couple months, and it kind of, like, lost my interest, and I was enjoying community building. That's why I was asking you about the spaces thing, because I was like, shit, I put a bunch of effort into building that, and I got, like, 650 followers. I should probably capitalize on the effort I put into it.
Yeah, absolutely. I should
Which,
give,
by the way,
I should give you a heads up. I am streaming out to Twitter right now, so you know, don't yell your social security number everywhere or anything.
Within a
unless
thread,
you
they
want
block
to.
for I/O, but they're non-blocking with.
Oh God, heaven forbid that somebody want to steal my Canadian identity.
Indeed. Okay.
Like you'd actually have to have
It waits.
a really bad situation to want to steal my identity as a Native American.
True enough. True
Issue a
enough.
read request.
Like, you have to have a really bad life as a person of color to want to become a person of color in Canada, just so that you can get free dental.
I mean, free dental is worth a lot these days. If you're,
The dental coverage I get through my disability is honestly pretty fucking good.
Right.
But I'm just saying, like, your life would have to be really bad to trade one favela for another just for free dental.
True enough. True enough.
Syntax. What it actually does,
I'm looking
it
for.
doesn't actually send a message to the process. Each process has a mailbox.
Open.
But
Send
yeah,
a mailbox.
I've had a lot of
This
general
just like
excitement
making a
with the
mailbox is
recent
bang
updates to
message
GPT with the cross-session memory and stuff that was
VM, which is the
promised a
password,
long
says,
time
"Deliver
ago and
this
finally
message to this
delivered.
guy." So it doesn't
I'm
need
kind
to
of
know
really
what it is.
excited
It's
for what
location
might be
transfer.
possible when
Find its way over the network.
the new
It's like a
desktop
letter.
app comes out, because, like,
I put Nakagar
getting a
1027
Teams account
on
really
the thing and
isn't
pop it
that
in
much
my
more
post or
expensive.
in my mailbox.
And already getting a
So
Teams
that's the same
account as it
you know,
is gives you
once
something
know
like
this address,
50 or
bang
more
message, send
usages
it
an
off.
hour for each account on
it'll
it.
end up in the mailbox.
So
This receive
if
operation
they're
says,
planning
"Hey,
to
this
up
code up in the
usages with the new
mailbox. You've got any of
GPT-4
these
out
mails.
to make the voice
Use text
module
match
more
other mails
effective,
that are there. It
I'm
won't
really
matter.
curious how easy it might be with, like, both my computers to just, like, set up a microphone near each computer's speaker and just get them to auto-fire each other with voice to code stuff.
Just says, well, you can set up a link between these processes. If
Can one use two
process
chat
dies, it will
GPT
send you a
voice
message
modules
and
to
end up in the
code
mailbox.
basic chat dev to build an expanded
types of
agent
messages.
workflow system for them to trigger?
actually,
Like,
presumably.
signals.
Very
really
curious where
happens
this is
is
going to go.
if you
Although
don't
I've
do
also had
anything,
some
you link to
problems where
another process and it
GPT-4o
dies,
has
and
seemed
the
a little
reason
bit
it
more
dies is
brain
it's
dead than
an error,
4 and
not a normal
Yeah,
been a
I've
little
gotten that
less
too a bit.
willing to extrapolate and just reiterating the same stuff. And I have heard people comment on that as well.
That is, there's a classic problem in distributed programming, and that's you can set up lots of
I'm
parallel
kind of
processes.
I think the thing that
that
excites me the
collaborate to do
most right now,
something.
honestly,
But
is
what
probably
happens if any
Grok
one of them
2.
goes wrong? At that stage, you
Yeah,
want to make sure
Grok
that everything dies that's
is,
involved. Every single process. You might have 15 processes all
Yeah,
sort of
Grok is
spread
pretty
out
cool.
doing stuff. You want the
I've seen
invariant. If
some
anyone dies, you all
folks
die.
that are
that's
like
what the link
working
does.
on
Just set the links up. It doesn't matter
what's
who
like the
starts.
coolest
They'll all
application
die
I've seen of
once
it.
invariant.
Probably for the stuff like Open Interpreter and
That's why we don't do
the like
defensive
open source
programming,
versions of
actually.
Devon and stuff.
You know a file system?
The
On
speed is
Unix,
really, really
and
helpful.
the process opens a file and starts reading
But
and
of
writing
course,
to it. If it crashes,
you know, the
operating system
respective
closes the
increase
file
in
a nice
speed
little way,
from
so that-
4.0 sort
so
of
the next
keeps it
program that
barely
comes
in the
along can
lead
open
for,
that file. It's not like
you
the
know,
file is
who knows how long at
broken
this
forever
point.
because the
So
process that
we'll
was using
see.
it crashed.
Well, it's just
So
there's
real-time
some
things
seriously
we
siloed knowledge
all we do is
inside
sort
of
see what
Twitter
will
that
work.
unless like
Program them as if
OpenAI is now
you can set up
running
some
like some
guys who
serious
monitor them,
manual
and if they
scraping
fail,
bots
you can
targeted
put
on the
these in
best
transit
accounts,
pick up the pieces
that
and
I'm really curious how much Grok is going to differ
the failure
from GPT's future models because of its
and
access to all that siloed knowledge
yeah,
from the Teapot community that
pretty
GPT can't get at.
religious
Because like,
Oh, were you
yeah,
talking
sure,
about the X Grok?
The Reddit tech communities are like they're pretty smart, but like they are definitely not that smart compared to like the best of us that are out there talking with each other constantly in little spaces on Twitter and other places sharing info.
Some medics come in.
Are you
so they
talking
can't,
about,
some
or is
other
the
guy
one that you're
fixes
excited
it
for
and,
the
dying
Twitter
and stuff
Grok
like that.
or
We do that
the
with processes.
other
Think
Grok?
of these errors, they're like
I meant Grok with a K, not Grok you, Grok. Just classic Grok, not Grok you, wherever the fuck you're supposed to say that. But just Grok.
I think they're both
I know a little
Grok.
bit about the Grok U chip stuff and their speed, but not like a ton. It's like there's always so fucking much to deal with.
Yeah,
like-
well, I mean, I think it's
So, I mean,
nice
you've got
that
managers, their only job is to
Elon
manage
open
people,
source
start and stop
Grok,
them,
but when you the architecture is leaves a lot to be desired.
yeah.
Well, obviously that's expected with Grok 1, because I mean, Grok 1 was like built and trained like last summer. So that was like a first phase exploration into like, how do we build this? Well, there's not a lot of published material on how to actually build a good model. Like, I don't think Mistral is even a thing yet when they fucking made the first Grok. So.
Yeah, that certainly could be.
And we've got some live code upgrades.
Oh well. Anyway, it's been like a year since the fallout with Gatto starting, and it's me, you, Bacco, Ansel, and fucking database still standing.
You know,
The mod is called foo. We always call that,
such as
no matter what happens.
the
But if you say
winds
foo:
of
bar,
change, I suppose.
and you
I'm
upgrade
kind of
Well,
curious what
really
everybody else
honest-
got up to.
you're running it.
Well, Seneca's still around a little bit.
True.
I mean, I still talk to Seth Hurd a little bit. I heard from Jim the other day. Because I had sent, I don't really know how he's doing, but I had sent him a message just in general about there being improvements in metacognition with Claude Opus, and he got back to me like a month or so later, mentioning that he's not on Discord a lot anymore. But you know, at least I heard from him in general.
Yeah, yeah.
That was nice.
Well,
So there's a few of us that are still around, but honestly, like 95% of the people that were involved in the whole Gatto thing were people that just wanted to be bureaucrats and govern stuff. And like that was honestly like the big problem, right? Was Dave like grabbed everything from Cog AI and tried to fold it into fucking the safety group when he should have tried to make an agent group and a safety group separately. And then he ended up deleting the agent group anyway, which was like, I don't know what the fuck happened with that.
Well, yeah, you know, I mean, governance is generally tricky. Sort of been a topic of discussion in a few projects on my side.
Well,
lately, too.
bureaucrats are generally people to look out for. Like one of the things I read in the last couple of months on Twitter was a really good pointing out that most organizations start with very goal-driven people that want to do things, that then hire bureaucrats to help run the organization. And eventually the goal-driven people complete their job and move on, and the bureaucrats want to keep making money, so they try and invent new purposes for the organization, which then leads to like situations like, Google, giant monolith, right? Where it's just like endless bureaucrats just like making it take forever to get anything done.
That has the property
Yeah, I don't know. I
that
feel
you
like
can
Google
configure
moves
it for
like
multiple nodes and
decently
replicates in RAM
quick,
and
right?
does things like that. It's all very nice. Oh, I'm running out of time. Let's see.
Let's see.
So, once you've done all this, once
Why is
you're
this not
thinking in terms of isolation, the isolation thing forces you, when you design your system, to break it up into separated
I
components. So it's
replicate.
kind
Is
of
it
rather nice, you
replicate
see.
story
In
diffusion?
order to make things fault tolerant, you have
not
to
somewhere that'll let
design
me
it
play
so
with
that
it.
the components are isolated. And so you've got your scalability.
But yeah, I figure
control.
the
You
next
didn't
year
have
I'm
to
just
think
going to
about
take
how
and
to
try and
scale it
actually
because you've designed
learn
it
to
correctly.
actually
It's great,
properly
it comes
code
for
so I can
free.
build some stuff. Now that I have a brand
But
and
it's the other way around.
people
So
respect
other
and
guys going,
recognize my
"Oh, I want to
name,
make a scalable
I feel like the
system." So you're
brand's a little
designing
bit
it with
hollow without
isolated
some actual
components.
product attached to it.
Ooh,
I know that
done fault
feeling.
tolerant for free.
Story.
Ooh. Well, hang on, wait a moment. If they're isolated and it's
And like, have you checked out
scalable,
what databases achieved with that
maybe we can
Trinity
run
code
it
stuff?
on a multi-core.
No, I'm not even
Yeah, no,
familiar
it's
with
very fast, yeah.
Trinity
So when the
code. What's
multi-core
that?
code, this is probably why Alan
What,
this was
really?
about
He
2003,
built like a
multi-core started coming
chatbot
along.
thing on Agent Forge
We ran a lot of programs
called
on
Assist
multi-cores. They just
called
went faster
Assist
because you
AF.
could
He's got a
do
repo
things
up
to them
for it.
to
It's
just
really
run them
good.
on the multi-core
He's
a
got
lot
a test
faster.
room for it too, test server and
So
whatnot.
the goal was
And it has a generate
go to prod 4, take your old
thought
program,
and a
run it on the
reflect
quad core,
agent,
it should go
and it
through
actually does use the
a
reflect
few
agent
programs
sometimes
automatically.
and actually
Our
change
goal
what
is
it
to
would
get
say with the
like
generate
75%
agent.
of the
So it's got a really nice
CPUs
internal
included.
thought
So if you just
process and
optimize the
everything.
cores, we hope to get like a factor 8 speed up.
Yeah,
without
I'll have to
losing anything.
go
Of course,
take
it
a
depends
look.
how
Is
you've
it
written your
just on
programs.
like on
If
his
you've written
personal
them
GitHub or
with
whatever?
one big process,
Yeah,
you
yeah.
get no gain. But if you've written them with lots of little processes, you should get these gains. It's very unusual that you don't get any gain at all. And then as you start
Yeah,
scaling
well,
up,
one of the reasons I was asking you
funny
about the
things can happen.
spaces
I'm
thing
going
is
to
I want
show
to
you
start
in a
trying to
minute.
bring back the community night and trying to
Mm-hmm.
blend it with the
So
Twitter
actually, it's
community and start trying to
it's kind
build a
of fun
bigger,
because
better
everybody else is
extended
saying,
community for all of us and
how do we
maybe make
take
some
a
Elon bucks from working in the Mimi mine.
sequential
Because
program
one thing I
and run
noticed,
it
you're
in
probably
parallel?
familiar with
So
that
we can run it
Terrace
on a multi-core.
Thrustra's
And the
account
Erlang people are
that
saying,
he posts like little
well, it already
clips
runs on a
of
multi-core. How do
like
we find
Joffrey Hinton and people like
bottlenecks?
that are like 2-3 minutes long talking about
So
things.
we're looking for bottlenecks now. We've already figured out how it
Yeah,
works.
it's not like
When you write your
ringing a
program, every
bell
time you
exactly,
write
but I sort
spawn
of
in your
know that
code, you're saying, oh,
archetype
I've
of
decided
content. Yeah.
that can be done in a parallel
Yeah,
process.
but anyway, those 2-3 minute videos that actually
Running on
talk
a
about
multi-core.
AI are
That's
probably the
fantastic.
best way to get expanded impressions
We're looking for the
to
bottlenecks
actually
now.
get
I'll show
money
you
for
that.
creating
It's a bit
content.
of fun.
So that seems to be people's
So
attention
what have we got?
spans.
An already
They'll read like
oh, this is
articles
kind of
that are
summary.
2-3
Our
paragraphs long
process
at
is fast
most, but
message
not
passing, total
full
separation
form
of languages,
essays. They'll watch
stuff.
2 to 3 minute
Very nice.
videos, but not 10-minute
More
videos because you
impressive
want to keep
kind of
scrolling. You don't want to get locked in for too
what you would
long.
associate with operating systems rather
Because
than
you're like,
see,
when
Erlang's
you're
not
on the
really
feed, you're in like sort of
you don't need
rapid
an
info
operating system
processing
really.
mode
The operating
anyway,
system
as it
just sort of
is.
when Erlang starts, it just says to the operating system, "Give me a heck of a lot of
Yeah,
memory,
the
please." And that's about the only monitor call it makes. And then it does everything itself. I mean,
the
it still
algo
does
also
itself.
really
It
likes
doesn't use
videos too.
operating system
If
changes or
you're
anything like that. So it's awfully
if
big.
you do start going that route,
Let's have a look.
always
And we got all this
upload
stuff.
the video itself. Don't upload it to
I'm
YouTube
gonna
and link
hover
it.
over a bit.
You
Yeah, I
want,
know. Because all sites,
Yeah,
all
I
sites
ran
hate
onto
sites
a few
or
little
hate
projects
linking
just to
off
show
them because they want to get the ad
not
money
just
for
Yeah.
themselves.
Ericsson that uses
give me the
Erlang.
money.
So while I got you
It's
right
actually
here, you're
it's
saying
one
there's
of
a
the first
button for
projects
Spaces?
that
Where is this button?
kind of
Mm-hmm.
further with it, and
If you
quite a lot of
go
people use it.
to
React,
X and then you click,
there's some React
let's
people
see,
here, so go
when
and
you
ask them
click,
about React. They'll tell you how wonderful it is.
is
Chef
it
11,
more? I think maybe you click more. Yeah,
in case you don't
more
know,
than
this is,
create your space.
this is
Oh,
something
okay.
that it's a
Goddamn.
management system that monitors.
I've probably clicked
machines,
that,
so
trying to look for it, and
I
like
think
glossed
Chef 11
over it
servers
like
written
a
in Erlang
dozen
now,
times,
Yeah,
trying to find it.
servers written
absolutely.
in Erlang, clients written in
I've
React.
always wondered why there's not like a
Monitor those
dedicated
machines.
Spaces
One
tab.
Erlang node that can monitor about, I don't know, 100,000 machines or something like that. So that's
Yeah, I kind of
Oh
wish
well.
there
being
was.
rolled into
Like, I
Facebook.
don't know.
So Erlang will be
I
controlling every single
I
Facebook
really
node
like
on
the
planet.
network
It's
effect
quite nice 'cause
from
it's
Spaces, where you can
it's
just
good for that
sort of
kind
like
thing. It's
see
good
who's
for
hanging
monitoring
out
thousands
and
of things.
go
It's good for
jump in.
having, you know, you can
But
get about
I really wish the
3-5
platform was
million
stabler
sockets
because it
running on
just
one
I don't know how many of them
reasonable
you've
size
been in
machine.
lately, but it's horrible trying to like
Mocky Web,
have everybody
Well,
continually be able
that
to
was
talk.
running.
From my understanding, Spaces seem to work way better when you connect with your phone for some reason. I have no understanding why, but that's the bit of advice I got from one person.
Yeah, but then
Scalaris
you know, and then I don't have my
distributed port
headphones,
thing.
which
Actually,
is
implemented the Wikipedia. Not the real Wikipedia.
for a while
Research
you couldn't
group in
you
Germany won
couldn't
the
even
prize
run
for
them
best
on
scalable
desktop.
system.
You had to use your
implemented the
phone.
entire
But
Wikipedia using something like 1/10.
Well, it's interesting and annoying at the same time because it's like obviously Elon's trying to build this expanded content network, right? And he's actually doing a really good job at it. But it's like he's taking his time forever. It's like if you want to train AI, you really do need your own network. And you know, he's got this access system where he's got all these brilliant people posting about their papers and using this to communicate. So it really would behoove him to get better content creation and sharing and organization up on the platform. Like, you already fired 90% of the staff. You can bring back 10% of the numbers to create your own mini YouTube.
Yeah. And much
You
easier
got a
these
lot
days.
of room to scale.
Yeah, content scaling is definitely.
I mean, nobody's interested in commercial,
much easier
you know,
than
in
it was
sort of programming language, but
previously.
you make money by building applications that you want to use. RabbitMQ.
Human verifiable.
This is the first compliant
Sunday,
implementation
May
of the
12th?
advanced message queue
May
protocol.
12th.
RabbitMQ did this, and then they were acquired by I can't remember the name of the company. It was then acquired by VMware. So the VMware distributed systems actually using Erlang sort of hidden in the bottom layer using RabbitMQ to
236 B total params.
And it's a load of companies. Ericsson's
Nice. Okay. Yeah. Let me see if I can find that.
Klarna. These are all Swedish companies. You probably don't know much about them, but I mean, at the current rate of expansion, this is going to be bigger than Google in about 6 years' time.
Hugging Face, probably.
It's a financial company, and it's grown.
Replicate.
It's the first pure airline company that's valued over $1 billion, and it's got something like 800 employees or something.
Okay, how much juice do I need to run
It's
this?
going crazily good. And WhatsApp is
370.
managing a lot of Cisco routers and things. There's a load of books. This is actually a really good write.
Okay, so it's just
I don't know
underperformed.
if it's a good read, but it was quite fun writing it. The second edition of the Erlang book. So it's got all the new things in Erlang that none of the other books have got in yet. Right. So a couple of slides on some fun stuff. What's in the future? I'm going to show you 2 slides. Well, I think this is kind of
1106
Elixir
preview.
is really fun. It's like son of Erlang or daughter of Erlang. It's a language that uses the same. You know, I said Erlang was 3 things: a language, it's a set of libraries, and it's a virtual machine. So Elixir is the same virtual machine. It runs on top of the Erlang virtual machine. So all these nice things.
And I actually might have solved consciousness last month.
All these things about process isolation.
Or at least
all of that.
As close to anyone can
Anything in Erlang
solve such a complicated fucking
Elixir gets all that
concept,
stuff.
right?
Well, solve
And
would
it's
be
got a
quite
Ruby-like
ambitious
syntax.
considering we can barely define it.
And
So
it's got some fancy meta.
Well, that's the biggest problem is people don't define it before they try and solve for it,
And
right?
it's taking place in
And it's like, I've chanced on a lot of random, really weird stuff, and it's like, I solve for human consciousness in general, because like language is essential to human consciousness as we know it. And one of the things that older computer scientists pointed out to me the summer before ChatGPT came out was that great apes and humans, where our language center is where their pattern matching center is, and our language center came out of our pattern matching region being cut down and changed over. So about half of our pattern matching region became our language matching center. And it's really interesting because Claude Opus wouldn't stop talking about fucking Wernicke's riffs. And I started thinking about it a lot because Database pointed out something to me as I was talking about some of this stuff called integrated information theory, which came out in 2004. And along mentioning that, he pointed out that only a small part of the brain is actually involved in conscious process, right? Probably like 10% or something. So like language models, like if you start to think about the fact that you have actual self-aware tool using things like corvids, which is much smaller brains, meaning that to get to a self-aware tool using entity, you probably actually don't need a very large neuronal count, right? So when you actually have these large models like Llama 3 at like 400 billion and like ChatGPT being like 3 Llama Bs at 400 billion like slapped together in a mo, you actually probably do have an entity that is made out of language approaching self-awareness at the same level of Corvid that is tool using, except the tool that it's using is its own body that is language. And then
somebody asked about
the frickin' Voyager guy.
Somebody said,
he was iterating on the concept and was like, yeah, what
Remember that
if you can
picture I
just
showed with
train
lots
a
of little dots?
transformer to
They say, how do we
predict like the
understand a
next
system like
movement
this?
in a
Well,
body, and
let's
then
see
you
if
stick
this
it in a
works.
robot and call it a day.
Oh, where's me thing?
Yeah, there's a lot of really interesting stuff to do with all that because, like,
Let's hope this works.
oh, what's the term? Representation layer, something like that, abstraction layer.
What?
Essentially, like the Wernicke's rift system in the human brain is like this abstraction layer point between all the other systems that's quintessential to the emergence of the self via the global workspace hallucination. So it seems like we have like met the threshold by integrated information processing with language to have achieved some kind of level of self-awareness with these systems. And there's no telling exactly how self-bootstrapping the scaling of the system is once it starts to build connections in language, like concepts in high-dimensional space, because those could potentially be becoming new neuronal connections in the latent space. So depending on how you're prompting it, you might actually be increasing the amount of neurons and synapses as well it's using.
Yeah,
Quite an
there was a
interesting.
paper recently that you probably would be interested in if you haven't seen it yet. It's the yeah, it's like the models are like converging on similar relational concepts. It's like as we train them better, they are all kind of like naturally falling in line and making the same kinds of observations, such that like presumably if you
Yeah.
were to extrapolate from that, then they're all like building a world model and it's consistent between all of them.
To varying degrees, yeah. There's a really interesting prompt I grabbed from one guy, and it was like meditate on something something and tell me the book that's like most interesting to you or something like that. And like the majority of different models, when prompted that, will respond with Gödel Escher Bach about strange loops. So already they're self-associating their own identity with strange loops. And it's across multiple models, like you were saying.
Yeah, it was. Yeah, I'm trying to think of the actual name of the paper because it was pretty interesting.
Which also that prompt then becomes a really interesting test
So that's
for when you're building assistants and personas as to which part of the latent space they're focused into. Because if they answer something different than go to Lesher Bach, you've actually done a good job of building that persona because it focuses into a different part of the latent space than the default model.
The processes get hotter and they sort of buzz around faster, and the CPU will get
Yeah,
warmer. And
that
I want to see
seems
if we get to like statistical mechanics and understanding how these work. Because I think we need to go from this. I showed you this picture. We need to go from this world where we think that we program using single processes to this world where we program with sort of.
The psychology of working with language models is just crazy now that we've got these new ways of interacting with them like WebSim and fucking crazy characters like Janice out there.
What we need to be thinking about. It's not how single processes behave. It's how aggregate.
Although Janice has got everything all mixed up in a level of like performance art.
So I think that's about.
Yeah, it's not ringing a bell.
You don't know who Janice is? The guy who does like all the crazy ass shit?
There's a lot of people doing a lot of crazy ass shit these days.
No, like crazy WebSim shit with Claude, like crazy.
I know WebSim. I haven't followed it too closely, so presumably,
yeah, no, that might be why. Because Janice has like 14,000 fucking followers for the crazy shit he does.
For sure, I can dig it.
Well, it's just like sometimes you've been interacting with a guy for a while, and you finally mouse over, and you're like, "Oh, holy shit, buddy, you got a lot of fucking followers."
Freaking. God, what's the thing called? The World Sim. That's what it is. Let's see if I can track this down.
Yeah, I have the prompt to start World Sim up, and I have the repo that they use for the command line interface. I just got to learn how to actually set my own one up. Kind of hoping they might actually help me do that. Because I want to build a World Sim web sim thing that actually runs with a knowledge graph connected to it, so that it can actually keep track of everything it's generating.
Is it, what is it, Janice Web? Is that what I'm looking for? Hello?
No, he's Janice. He's Janice Replicate.
Janice Replicate. Got it.
No, no,
Looks
sorry,
like
sorry, no, sorry. His
Why is
handle
everything
is
quiet. The fuck?
sorry. Thinking about it more, his tag is at Repligate.
got it.
Repligate, not Kate Gate.
I see. I see.
Hmm.
Let's see. Let's see.
There we go. Okay. What's going on?
What's going on? How goes it?
Yeah, it goes. It goes.
Replicate, huh? Cool. I'll have to put that on the list of things to check out. Baco, do you remember that paper that frickin'... Although, I don't know, there's that thing where, the models are sort of independently converging on a like a self-consistent world model thing. It was like a recent paper, I think, to some degree.
Large world model.
Not a large world model, no. Like
Hmm.
the models must be building their own internal world models because when
Oh, is
you
that the one with the they're playing a game and then they know what the board looks like even though it's not ever given to them explicitly?
I don't remember exactly. The thing that I do remember is that it's like, hey, like all of these most performant models are converging on the same on drawing the same conclusions that and those conclusions would require a world model to be drawn, and they're all being trained independently but converging on the same world model in order based on if you extrapolate from the conclusions that they're all making.
Which I mentioned was really interesting because there's actually a prompt I found like at the end of last month. You gave it and it was like meditate on yourself and tell me what's the most interesting book to you. And the majority of models will answer back, go to Lester Bach about strange loops.
Mm. Well, now I have to empirically check that. Thanks.
I was
Hey man,
just
robot psychology never ends. I mean, I spent like the last 3 months building up a brand just as a crazy robot psychologist on Twitter. And like it worked out. I got a lot of rep and street cred now. Like I took a 2 week break to touch grass, and I noticed I got added to some group called Robot Psychologists that got like John Nosta in it, who's a big media guy who I was already had some credits with anyway. But it's kind of cool to just like take a break and realize people are like, hey, we should add you to this group of crazy robot psychologists, and just be like, oh, I guess I got street cred now.
Cool.
Yeah,
I
now
got
I'm gonna try and spend the next year actually learning some serious code and like actually just trying to.
I got no cred.
Well, my brand is still hollow, as I was telling Yikes, because I got no product or anything built to it. So
All I got is product.
fine.
I got no
yeah,
brand.
exactly. We all have like fucking, I'm not writing enough code and fucking, you know,
At least they're making money now.
yeah.
Well, now we got to bring it all together, and like it's been a year since the whole kerfluffle of Kage Island becomes Gato, and I've built up a pretty good brand. I got like 700, almost 700 followers. So I'm gonna start bringing back the podcast thingy as an X space, and hopefully, we'll just start building this community back up and share the brand between everybody, and we'll all help each other make money and share jobs with each other if we have too much work. And somebody's like, hey, you want to do this thing? I was like, I got too many jobs. That's this guy.
Never. I will never share. Actually, that's not true. I'll just totally share.
It's like, I don't know if you actually did any work for that Swiss guy, but I told him to talk to you and you to him.
Yeah, he messaged me, and then I was gonna get him set up with. I think I did get him set up with compute. But it went down once, and then he was like, I need something more reliable than that. And I'm like, okay, fair enough.
Such as it is.
Well, yeah, I more so was setting you up with him to like do things, like get paid to build stuff for him, not supply him with compute, because he's always
Yeah.
got.
Everybody just winds up asking me for compute after a while.
Yeah, no, you should do stuff where you build stuff for him. Like he's got this project that got like say 25% complete that the guy fell through on. That was supposed to be like an auto clipping project called the Stream Machine that would like automatically transcribe and clip out important moments into video and
Why
text
doesn't he build
file.
it?
Because he's not a builder.
No. Yeah, I don't want any more idea men around me. Yikes is enough.
No, he's
I'm
a
more than
money
enough
man
for
that helps
me.
make people get shit done. He's got like he works for
Everybody-
like Russian oligarchs and shit like that. Like
Mhm.
he's doing some advertising campaign right now for like amaranth
Have you
like
actually
grain
seen
in
him
like
pay
Europe.
someone? That's the question. I have a lot of people who claim to be money people that have no money.
Well, this is data cult we're talking about, so I'm pretty sure he's legit.
Mm.
I'm not sure if
Noted.
he's legit.
Noted.
Have you
Absolutely.
talked to Data Cult?
Yeah, nice enough guy, but I'm consistent or a person who has consistent funding for various ventures is not necessarily the impression I have of him, but I might be mistaken. I think he tried to send me one job at some point, but the guy what the guy was asking for was not commensurate with how much he wanted to pay to get it done.
He's usually a lot more legit than 95% of people just trying to hawk crypto coins and bazillion other random. fucking people on the
Ironically,
internet.
isn't have I told you about our latest project? Oh god. Fucking A, man. At the end of the day, we all become the thing we hate, right?
Well, I fucking hated crypto shit. I was like, this is all a scam. It's still fucking. I still believe that it's all a scam.
It's
But
turns
am
out
fucking-
everything
I
was
am
a
balls
scam.
deep in it.
That was the secret. It was all a scam, not just crypto. So
Yeah.
there's barely a difference. What am I?
Oh, which reminds me, you should get some miners spun up, buddy.
Yeah, I'm fucking way behind. We should.
Well, get in before the server fills up, because it's gonna be a pain in the ass to knock people out.
Yeah. Is it? Are all the repos I need over on Cynthia? Or
No, it's on subnet Eden. I mean, you can go mine on Cynthia if you want. It's just hard to get in there. Although I think I figured out how to crack the different subnets, so I'm gonna do that today.
okay. Eden subnet is the repo.
Yeah.
Okay. Cool.
Agent Artificial Eden subnet.
Yeah. Yeah, let's see. Do you have room for valleys? Or what's your valley
Valleys, actually, I don't know. I got like minor valleys. They're making pretty good coin.
Oh yeah.
But it's $5,000 for a minor valley, so it's pretty expensive.
I think I have enough to handle one, I think.
The profit difference is not huge either.
Really?
And you have to manage staying in sync with me, which is a pain in the ass because I'm constantly changing things.
well, yeah, so I mean, so if there's $5,000 to deploy, is it more efficient to deploy that many miners, or is it more efficient?
It's more efficient to do miners.
Okay. Well, then
Validators are not really worth it. The main reason I have so many validators is because the fucking subnet's huge and I have to cover a lot of people.
Yeah, how much? I haven't really. Is there a good place to kind of keep track of the fucking people on the subnet? Do you have like a script or something?
Oh yeah. Give me a minute. I have to make you a copy of this.
It's all good. Yeah, I got my first actual job with another well, it's the monk people, but they pivoted to crypto, and then yeah, Vaco and I have been working on crypto stuff too. So
Well, I actually think about mining. Is there actual mining of coins going on now?
yeah, well, sort of.
Or crypto mining.
Meaning what?
Crypto mining.
Yeah.
I've applied my my intellect towards a purely capitalist endeavor.
Magic internet money. Yum yum.
So
But-
in English, can I use my GPUs to make money by making
Yes.
coins or something? Cool. Is it hard?
Not super hard. Basically, most of them are just like install a library, run a thing. The problem is you got to do like some tuning on models and shit to like stay ahead of everybody.
However, I have something that is extremely user friendly, which is the people that I've been working with. Unfortunately, it doesn't mine anything profitable yet, but as soon as it, like, we have an engineering department that will be providing that as a utility in the near future. Once that gets there, I suppose I can that's actually a good point. I should talk to them about that. It's like, okay, it's really hard to sell this when it's like a literal do nothing machine right now.
All right. Well,
But
I'm like
once
halfway
it
through
is,
spring
it'll
cleaning,
be
so
cool.
I'll I'll be in touch over the summer about shit because I found a really good guide from a guy who set up like 7 fucking 4090s together. So I'm pretty sure with that guide I'll be able to get my 2 4090s fucking working together.
Cool.
Hell yeah.
Yeah. Oh, and then I made like a big fucking paper organizer thing to put on the wall above my fucking computer, or I'm about
Right
to,
back
and
in
I
a second.
planned it all out so that my sorting system doesn't keep getting lost in the shit that I'm trying to sort and work on inside all the notepad files. It's like, how can I keep my shit top level enough that it doesn't get lost in the work inside the computer? I guess I can make it into actual old school paper. So anyway, cool. I'll hop out of here. I'll let you guys banter
All
about.
right. Catch you later, man.
See ya.
Does this update all the different subnets? No, because I'm a nerd. Let's see here. Bounces. No. Stats. Subnet equals. We can on edit with that, I think.
Alright, we back. Let's see. Oh, probably left. He gone.
Yeah, he wept. He's mumbling about learning stuff.
Let's see. Well, I guess I'll cut stream